So, yesterday we talked about vertical transformations. Today we're going to talk about horizontal transformations. And we already had all this discovery conversation when we did these notes. We had all this conversation and deep thought about, like, we graphed a bunch of stuff. So I've already got it graphed. We're going to talk about it because there's a really obvious pattern. Well, there's a pattern, and I want you guys to see if you can figure out what it is. Okay, so first of all, yesterday when we talked about horizontal reflections, the only one I have anything cutesy for is this. So for horizontal reflections, all the single ladies. And what do all the single ladies do? Because, you know, if you like it, you should have put a ring on it. So they, right? They turn the hand, right? So that's what we're going to do. We're going to go like that. I mean, let me zoom out. Maybe we can. I'm sorry this is happening. I'm really, really sorry this is happening. Okay, so when we do a horizontal reflection, it goes from this to this. It goes from this to this. So we take it and we flip it like that. So instead of going like taking a bow, we're turning it basically so that it faces backwards. Okay? Because if you like it, you should have put a ring on it. That's all. Probably going to get flagged for that. Okay, so I don't have anything cute for the rest of them. What I'm going to do is I'm going to write down these functions and we're going to look at the graphs. Now this one, yeah. So this one is f of negative x. Okay, a horizontal compression is f of bx, where b is greater than 1. This is f of bx, where b is less than 1. This is f of x plus c. And that's f of x minus c. So write that down, and I'm going to put some examples down at the bottom so you have just some numbers to go along with them. Okay? There's nothing to do with that one. And these are the functions that I have graphed if you choose to go through and regraph them. Okay, so let's forget the reflection. Okay, the reflection itself. F of bx, when b is bigger than 1. So when we had, y'all write that down. When we had a vertical, when a was bigger than 1, right? So if we look at this one here, when a was bigger than 1, what happened to it? Well, but like it stretched, right? It was a vertical stretch. So when b is bigger than 1, you would think that it would be a horizontal stretch, right? But it's not. It's a horizontal compression. So you'd think that it would get wider, but it actually gets narrower. Okay? Oh, just wait. Let me blow your mind some more. Okay. Now, when we have, so yesterday when we had we had f of x and a, when we have a f of x and a was less than 1, that was a vertical compression, right? So you'd think that if b was less than 1, it would be a horizontal compression, but it's not. It's a horizontal stretch, and the graph gets wider. You're like, what the what? Right? Okay? So, I'm going to need to draw a little number line here for y'all to kind of see this one. Y'all don't have to draw this if you don't want to. Okay. So you see how this says x plus c and I have x plus 4 here? So based on the number line, which way do you think that would go? Right, right? Because the numbers get more positive when they go right, except you don't. You shift left. You shift left. Okay, and you see how this says x minus c? Looks like that would go left, right? Because the numbers get, nope, you shift right. You shift right. And you can see it here. So this is f of x plus c, and look, it shifted left. F of x minus c shifted right. f of bx, where b is 1/3, it's stretched, it's horizontally stretched, not compressed. So everything's happening backwards here. And that's what's especially awful about horizontal transformations, is that, well, and I just want to point something else out to you. Look at these graphs. They look the same. When I shift up, it looks the same as shifting left. When I shift down, it looks the same as shifting right. A horizontal stretch looks the same as a vertical compression. Do you kind of see what I'm saying there? So they look very similar, but when they're linear. Now, when we get to quadratic functions later on, it's going to be really obvious what's happening. Okay, so how many of us don't like this? Yeah, me neither. It's confusing. So there's two ways we're going to figure this out. So real quick, let's summarize what we got here. We'll let that settle in your brain, and then I'll show you the two ways I'm going to have you try to remember this. Okay, so first of all, let's talk about what our changes in B look like. So we have two possible changes in B. Okay? So we have one, I'm sorry, this would be 4, right? Because we have 1, 2, 3. This is our fourth possible change, is a horizontal reflection, which is negative f of x. Oh, that's wrong. Don't judge me, or do judge me. F of negative x. Sorry about that. And in this case, B is negative. Okay, let me zoom in a little bit. Okay, the next thing that we could have, negative. Okay, the next thing that we could have is we could have a horizontal stretch. Okay, and that is f of bx, where b is less than 1. Or we could have a horizontal compress, also f of bx, but this time b is greater than 1. Okay, so those are possibilities. Now remember, the reason why I say that this is only one change is because I can't stretch and compress at the same time. So I'm not going to see both of these happening at the same time. I'm going to see one or the other. Okay? So that's the first part. Let's write down what we could see for changes in C. And this is the last one, and then we're going to start figuring this out. We could have a horizontal shift left. That is not a clock, it's an L circled. Yeah, which is f of x plus c. Or we could have a horizontal shift right, which is f of x minus c. Take a minute and write those down. All right, so there's two ways I'm going to show you that you could remember. Now, last period, okay, this is not, mine says IHOD over, but they actually added next to O here, they added OPP, so it says I hopped over, which sounds good. I can get down with that. And I know there's no E, but whatever, it's going to be fine. I hopped over, okay? So I'm going to show you what this means. And then there's another way I'm going to show you to remember it. So there's two possible ways. You can either remember it with IHOD over, or you can remember it this other way. So, first of all, I hope that you notice that everything horizontal is happening inside the parentheses, and everything vertical is happening outside the parentheses. Okay, so the first thing that we might notice, so we have IHOD. What do you think the H stands for? horizontal, right? I would say horizontal change. It's a horizontal change. So then what do you think the V stands for? Vertical change. Okay, so we have a horizontal change and we have a vertical change. I'll do my highlighting later. Okay, now where do the horizontal changes take place? Inside or outside the parentheses? Inside. So the I stands for inside the parentheses. And then what do you think the O in over must stand for? Outside the parentheses. Okay? Now, what do we know? What have we learned recently that starts with D and R? Domain and range. Okay, say, well, domain is my x values. X is my horizontal axis. So when I'm having a change, when I'm having a horizontal change, that's a change in the x. So then what would this be over here? The range, because vertical changes affect my range. Now, I just got done telling you that everything I think is going to happen is the other thing happens, right? So I think it's going to go left, it goes right. I think it's going to go right, it goes left. Ah, the O stands for, okay, behaves opposite of what we expect. Okay? Remember opposite. Okay? Like the children of the corn. Oh my God, you guys have been children of the corn lately. Okay? So inside, horizontal, opposite, domain. That's what IHOD stands for. Inside, horizontal, opposite, domain. IHOD.
What's that word for O?
Opposite. Outside, and it's got parentheses next to it. Outside of the parentheses. So see, I put the parentheses outside.
Oh, the IHOD over.
It says behaves opposite of what we expect. Opposite. I said it like 6 times.
I know what's opposite. But I couldn't understand.
Behaves opposite of what we expect.
And I guess he's like expected.
Yeah, and so the E means it behaves exactly how we expect. Okay, so if it's inside parentheses, it's a horizontal change. It's going to behave the opposite of what you expect, and it's affecting your domain, your x values. If it's outside the parentheses, it's a vertical change. It's going to behave exactly how we expect it to, and it affects our range, our y value. So this is O for outside, V for vertical, E for expect, R for range. Okay? I hopped over. Okay, so that's one way to remember it. Honestly, it's probably better than the other way I'm going to show you. Okay, so here's the other way. You're going to write just one little phrase when we're done, but don't worry about it. Okay, so I'm going to assume that some of you may or may not have, like, I know you're like 13, 14 years old, but I'm assuming that y'all have maybe, like, dated somebody and then broken up with them. So what happens? So, like, a lot of times when you break up with somebody, it's because they're not trustworthy. Right? So like they say, I'm not texting them. I'm not texting that girl or that guy. I'm not texting them, but they are. Or they say, I'm not eating lunch with her, but they are. Okay? Or maybe they say, you say, hey, what do you want to do something Friday? And they're like, ooh, I can't. I'm going to stay home with my family. But then you find out they went to the movies with some girl. Right? So they're not trustworthy because they say they're going to do one thing and then they do something else. Now, maybe one day you're like, I think he's sitting with that girl. And you're like, that's it. Hey, Mrs. Deal, I need to go to the bathroom. So you get up and you go to the bathroom during lunch. And then you maybe go past the bathroom and you go to the cafeteria. So you can see with your eyes, you can say, hey, is he sitting with her? Maybe he is, maybe he isn't. Okay? But if you see it, like you at least know what's happening. right? So if you see it, if you look and he's sitting with the girl, you know he's sitting with the girl. It doesn't matter what he says, he's sitting with the girl. If you look and he's not, it doesn't matter what he says, you know he's not, right? So your eyes, you believe your eyes, but you don't trust him anymore because he's your ex, right? You guys with me? Okay, great. So write this down. Trust your eyes. Your exes lie. Okay? My exes, they lie to me. My exes say, hey, I'm going left, but they go right. They say, hey, I'm going to go right, but they go left. They say, hey, I'm going to stretch, but then they compress. They don't do what they say they're going to do. My exes don't. But my Ys do exactly what they say they're going to do. If they say they're going to shift up, they shift up. If they say +5, that means they go up 5. If they say 3 times, they actually get 3 times taller. They do exactly what they say they're going to do. Okay? Not only do I trust my Ys, I also trust my eyes. So if I look at this graph and I see it going left 4, then it went left 4. Okay? This is what I don't trust. I don't trust this. This lies to me, but my eyes tell me the truth. Whether it's going left or right, up or down, if I see it going left, then it went left. If I see it going right, then it went right. I trust my eyes. My exes lie. Okay? That's your 2 possible ways to learn this. Hopefully some of that actually helped. But I will assure you guys, even if this doesn't make a whole lot of sense now, by the time we get to quadratics in the second semester, this is going to make more sense because the graphs, you're going to actually be able to see the changes happening. And a lot of times in linear stuff, you can't really tell exactly what's happening. So when we get to quadratics, it'll make a lot more sense.